Okay, so now we will be talking about the motion of a moving charged particle inside a uniform electric field. An electron is traveling with an initial velocity u and enters perpendicularly into a uniform electric field E between two parallel charged metal plates. The mass of the electron is m. The separation between the two plates is d, and then the length of the plate is L. Charge of the electron is Q. So now, when you see two parallel plates, and then one is positively charged, another is negatively charged, you know that the electric field will point to the negative charge from the positive charge. That means that the electric field is now pointing vertically downwards. And then you have to remember that the electrostatic force can only act on the direction of the electric field. That means that F equal to QE. When E is vertical, you can only expect the electrostatic force is also in the vertical direction. You can never expect the horizontal force from the vertical electric field. Okay? So now F equal to mA equal to QE. So you know that A equal to QE over M. Q is a constant. E is also a constant because E is uniform in between the plates. And M is also a constant. Therefore, you know that acceleration is constant. And then when you know the acceleration is constant, then only you can use those kinematics formula. Okay? So for example, in the simple harmonic motion, you know that the acceleration is directly proportional to the displacement from the equilibrium position. Can you still use these formulas? Of course not anymore. Okay? These formulas are only applicable when A is constant. So now I want you to show that the path of the electron inside the uniform electric field is a parabola. Okay? So now you consider the horizontal motion first. In the horizontal motion, we do not have any force, and therefore the electron is moving at a constant velocity u, because the initial velocity is u. So it will be moving like this. But then in the vertical motion, because there is an electrostatic force, so you expect that initially the vertical velocity is 0. But then when it experiences a constant acceleration, it will start moving. Okay? So it is like this. 0 velocity, slow, fast. Okay? It will have a constant acceleration in the vertical motion. Okay, so in the horizontal direction, s equal to ut plus half ad squared. No force in the horizontal motion, so no acceleration. And then s equal to ut. In the vertical motion, initially there is no initial vertical velocity, so u is 0. And then the acceleration is this. So from these two equations, you get rid of the variable t. Therefore, you can come to this equation y equal to something x squared. And then when you get this equation, you already show that it is a parabola. Okay? So find the maximum displacement of the electron inside the E. Okay? That means that the maximum displacement of the electron, okay, this one, the capital H. Okay, just now, we know x equal to ut. Let's think that the electron takes a time capital T to move from this position all the way to this position. That means that the time taken for the electron to traverse completely the electric field is capital T. Okay? I repeat one more time. The time taken T is capital T is the time taken for the electron to move from here to here. Okay, so now L equal to ut, and then when T equal to capital T, Y equal to the maximum displacement, because you know that the maximum displacement of the electron occurs at the end of the plate. Okay, so now you get rid of the capital T, then you can get the maximum displacement of the electron. So now you see, if the maximum displacement of the electron is larger than d over 2, then what will happen is that the electron will clash with the positively charged plate, and then the electron can never come out. If the h is smaller than d over 2, then it can come out from the ends of the plates. Okay? Oh, by the way, if next time the electron is moving here, then you change the condition. That means that if h is smaller than d, the electron can come out from the end of the plates. If h is greater than d, because it's like this, so the maximum displacement should be d, not d over 2. Okay, electrons cannot exit from the end of the plates. I use d over 2 because I assume that the electron is coming in between the parallel plates. Okay, so find the total work done onto the electron by the electric field. So in the horizontal motion, v equal to u plus at, and then you know that there is no acceleration in the horizontal motion. Then you say that the velocity is a constant all the way in the horizontal motion. In the vertical motion, you know that the velocity increases because there's an acceleration in the vertical direction. Okay, so after you know the final velocity in the horizontal motion and the final velocity in the vertical motion, you can get the final net velocity of the electron, and then you can use the difference in between the kinetic energy of the electron, which is half mv squared minus half mu squared, to find out the work done onto the electron. Or you can use work done onto the electron equal to q delta v, where delta v is the difference in the potential experienced by the electron. So Q equal to delta V equal to E times delta L, and then the delta L, you have to remember that the delta L is the displacement of the electron in the direction of the electric field. Okay, so delta L equal to what? Equal to capital H. Okay, delta L equal to capital H, then you substitute what is H. H is this one. You substitute inside, then you can still get the same answer. Okay, this is really important because this often comes out in the examination. That means that, let's say the proton is accelerated from this point X to the point Y. May I know what is the change in the kinetic energy of the proton? When you are trying to find the change in kinetic energy of the proton, of course you are only considering the displacement of the proton in the direction of the electric field. That means that you only take the 0.4 meter into consideration. You never take this 0.3 meter into consideration. This one is useless information, 0.3 meter. Okay, you ignore this thing. Okay, but then this is just a recap of what you have learned in the last video. Okay, I have shown you this in the last video. Okay, so now outside the arrangement mentioned just now, that means that outside the parallel plate, you now have a screen at a distance d from the plate. There is now a total displacement h on the screen. This one, the small h. The small h is larger than the capital H. Please find the small h. Okay, you know that inside the electric field, there is a force acting on the electron in the vertical motion. But then after the electron leaves the uniform electric field, the electron now does not feel any force, and therefore the electron will move in a straight line from here all the way to here. Okay, this is a straight line. This is a parabolic path. Okay, parabolic path, straight line. Okay, so because this is a straight line, so of course you can do a triangle, and then you try your best to find the y, the capital Y. The capital Y is from here to here. Okay, and then after you get the capital Y, then you can find the small h, because small h equal to capital H plus capital Y. Okay, you use a powerful geometry. Then the tangent theta equal to velocity in the vertical direction divided by the velocity in the horizontal direction. Okay, and then this is the final velocity here. Okay. Okay, another question. An electron moves along a line in the middle between a pair of parallel metal plates. The initial horizontal velocity of the electron is 4 times 10 power 6 meter per second. The electric potential of upper and lower plates are positive 6 volt and negative 6 volt respectively. The separation between the plates is 1 cm. Okay, and then the length of the plate is 5 cm. Please calculate the acceleration of the electron. Okay, F equal to ma, F equal to qe, and then E equal to V over d when the electric field strength is uniform in between the plates. If let's say one day the electric field is no longer uniform, then you don't have to use the formula E equal to V over d anymore. Okay, E equal to V over d is only applicable when the electric field strength is uniform. Okay, then you can find out the acceleration of the electrons, and please determine whether the electron can exit from the end of the plates or not. Okay, so you try your best to find the capital H, which is the maximum displacement of the electron. If the maximum displacement of the electron, let's say now the answer is 1.65 meter, 1.65 centimeter, that means that the electron will clash with the positive plate, and therefore the electron cannot exit from the end of the plates. Okay, and then you remember that E equal to V over d. The V here is the difference in the potential. That means that E is positive 6 minus negative 6. That means that the V is equal to 12 volt. Okay, V is the potential difference between the plates. Okay, a pair of parallel horizontal metal plates connected to a 4 volt battery is shown as below. Okay, the plates are separated at a distance of 2 cm. An electron is projected vertically up with a velocity of 9.8 times 10 power 5 meter per second through the hole A. Please determine the distance of the movement of the electron before it comes to rest. Okay, this is positive, so you know that this is also positive. This is negative, so you know that this is also negatively charged. Okay, once I see this, I know that electron is negatively charged. I know that the electron will move like this, then stop for a while, then come back slowly, then very fast. Okay, so it will have a motion like this. Okay, so you know that it will traverse a distance before it comes to rest. And then how do you find the maximum distance of the movement? There are two methods. First is that you use the energy method. Okay, the loss in kinetic energy of the electron is equal to the work done against the electric field. Okay, half mv squared minus half mv squared equal to work done equal to Fx equal to QES equal to Q delta V over D times S. You substitute everything inside, then you can get this. Or you can use this. You can use this because you know the acceleration is a constant. Okay, so but remember the acceleration now is negative. That means that the acceleration is opposite to the direction of the initial velocity. So you don't call it acceleration, you call it deceleration. Alright, and then you make sure that inside your A, you have a negative value. Okay, now if the distance between the plates is closer, that means that it's like this, closer, then what is the effect on the electric field and the distance of the electron movement? You know that E equal to delta V over D. When D decreases, E increases. When E increases, acceleration also increases, that means that the deceleration increases. Okay, so when the deceleration increases, therefore the distance can be moved by s, okay, will decrease. Okay, that means that just now the electron can come here, then come back here, but now since the plates are getting closer, the electron can only move a little bit, then it must come back now. Okay, so you know the distance move will decrease. So I think this is all in the chapter 12, electrostatics. Hopefully you can learn something from this. Thank you.